Hi everyone, and welcome to CTL's Education Professional Development Series. My name is Amy Al-Khalisi, EdTech Project Manager here at CTL, and I'm joined by Stephanie Shea, Marketing Manager. Sorry you guys, let me get you on the right slide here. There we go. If you are not familiar with CTL, we've been headquartered in Portland, Oregon, providing innovative IT solutions to education and government customers for over 26 years. We're Google for Education partner, specializing in rugged CTL Chromebooks, laptops, convertibles, 2-in-1s, and tablets designed specifically for K through 12. Over the last 2.5 years, we've worked with Google to introduce a line of CTL Chromebooks that have been recommended by PC Magazine as the best choice for Chromebooks in education. As part of our commitment to education, CTL offers free professional development on a variety of webinars on a variety of topics of relevant K through 12 EdTech. Today's webinar is an introduction to LabCam, presented by Amis Viola Bodo, Sales and Content Manager at IntelliSense. Before we get started, I just want you guys to review the interface so you know how to participate in today's webinar. You should see something that looks a little bit like this on your own computer desktop in the upper right-hand corner. You're listening in using your computer's speaker system by default. If you prefer to join over the phone, just select telephone, and the audio pane and the dial information will be displayed. You may type any questions into the question pane of the control panel during the presentation, and they will be addressed in a question and answer session at the end of the presentation. But before we begin, I'd like to take a poll to learn a little bit more about our attendees today. So please indicate if you've ever used LabCam. We'll take a moment to give you a chance to fill the poll out. So hang tight, let me launch this. All right. Okay, can everybody see that? Give you guys a couple seconds here. Since IntelliSense is newer, I know to us, I'm not sure there would be a whole lot of experience, but so let me see. I don't know if you guys can see this, but it shows that it's, as of now, there's nobody, 100% doesn't have experience. So that's good. I mean, it's a good and bad thing, but it's a good thing because we have a superstar Amis here to teach us. All right, moving forward. Thank you for voting, by the way. All right, before I give it over to Amis for our webinar today, I just want to remind everyone that there are some great resources here for Nevada 21 educators. When you visit the nr21.ctl.net website, you can learn about upcoming professional learning opportunities, sign up for events, and join the Google Plus community, the private community for the Nevada 21 educators. There's a lot of updated information on the Google Plus page. And feel free to post pictures of your classroom and what's going on, or updates, or even asking questions. All right, I would like to now introduce Amis Viola Bodo, Sales and Content Manager for IntelliSense. Amis is an expert in LabCam software, having represented IntelliSense at exhibitions and created demos for them. She brings her experience as an applied mathematician and former educator in mathematics and STEM subjects. Amis is in charge of marketing and user support, as well as sales and social media activities. Amis will now take you through an overview of LabCam. So welcome, and let me change presenters here. Over to Amis. And I love Amis's accent, just so everybody knows that.
Okay, so hello everyone. Can you see my screen?
Yeah.
Okay, perfect. Then I try to. Okay, now I went full screen mode. Okay. So first, I'd like to start with a quick slideshow to go through the basics as a reminder for those who attended the previous session, and for the new attendees to have a look at the big picture. Then I will change to the camera and show you some really easy to do experiments right here and now. Because I know this is always the hardest part to figure out how to actually build it into your lessons. So I will try to give you some tips on that. In general, lab camera is a science observation and exploration application with 7 tools, with which you can turn your computer, your Chromebook, into an actual science laboratory. It makes both teaching and learning STEM subjects more fun. The biggest Hungarian university, called ELTE, carried out a study in which children use lab camera for only homework, so not in the lesson, but they got the software and they could do their homework with lab camera. And as the slide shows here, their exam results were 10 to 15% better than those children who followed the traditional methods of learning. So we are really proud of this, this result. So now I will go through all the modules one by one and tell you the most important things about it. So the first one is called Timelapse, with which you can make time-lapse videos, obviously. But why this is special is that, as you can see here, you can change the time between frames, which allows you to make different types of time-lapse videos. So, for example, you can record the formation of clouds, which is not too slow, but also you can set the time between frames to 1 day, and then you can observe the change of seasons, for example, if you record for an entire year. That could be a very spectacular and wonderful video, I believe. So time-lapse can be part of many lessons: biology, chemistry, maybe earth science, mostly. Then we have Kinematics, which is more like for physics class. Here you can select objects by color and track the motion of these objects. The software can follow up to 3 objects, allowing complex kinematic experiments. For example, if you take 2 toy cars and want to observe how they collide, obviously you would want to track both of them, which is totally possible with lab camera. It can draw, as you can see here on the right, it can draw the diagrams, motion diagrams. It can draw displacement, velocity, and acceleration diagrams, and also not just during the experiment, but you can later save it in an image format or in an Excel sheet format, so that later you can analyze it. The next module that we have is called Motion Cam, which is rather designed for home usage and for home projects, because it's like a motion sensor camera. So, for example, kids can put out some food in the backyard and start the motion cam, but it will only record if it sees if it detects some motion. So if I don't know, a squirrel or a cat comes, then it will record. And then in the morning, it's really exciting to check what animal moved during the night in their garden. So maybe this is a good choice to life science or biology lesson. Kids like doing these sort of things at home. Then then here we go with Microscope. This name is a little bit misleading because it's so much more than just a microscope. We should call it something like a universal measuring tool, but it just doesn't sound so good. So we stayed with the microscope name. But the point here is that if you have an image of anything, you can make measurements if you have a reference value. So, for example, on this upper picture, you see onion cells. So, if you get some reference value here, I think in the corner we get some reference value, and then you can calibrate the tool and measure the size of cells, for example, or in this other case, you can measure things on the moon, so like the size of a crater or something like that. Where to use this module? Well, as measurements are part of all science subjects, it can be useful for all of you. So I really suggest you play a little bit with it and try integrating it into your lessons. The next one is Universal Logger, with which you can log any measurement instruments data. You can point your camera on the display of the device. So, for example, this one is a digital display. This is a liquid in glass type of measuring instrument, and this is this needle pointer kind of device. So you just put the template on it, and automatically it will recognize the numbers here and the level of the liquid in the instrument. And if you do some experiments, then you can log the data. The result that you get is such a diagram, which is really good because you can see the trends in the experiments, and not just the end result that okay, something got heated up to, I don't know, 30 degrees, but you can see how it was heated. Yes, it can be part of any science subject where you want to measure something. It's a very cost-effective way, actually, to do an experiment, because you don't have to buy expensive lab equipment, but you can use the good old ones. Just with a camera, you can log their data. Then we have Pathfinder, which can draw motion density maps. You can either load the video or do it in real time from the camera image. It helps you detect the unseen patterns and hidden routes in seemingly random motion. So, for example, in case of ants, I will show you this video a little bit later. For example, in case of ants, they seem to wander around randomly, but with our Pathfinder tool, you can draw you can follow their motion and then draw a motion density map. Of course, if I'm talking about ants, it's in connection with the biology class. But I will show you some other really cool ways how you can use it in class. And the last module that we have here is called Graph Challenge, which is more like a game, but children can benefit a lot, because throughout playing and having fun, they can learn how to connect the motion to their graphs. So here the task is to try to follow the shape of the curve. So in this picture, this girl has a ball in her hands, and she will have to follow the shape of the curve with the motion of the ball. So I will show you how that works in action. Okay, so these were the modules, and I put this slide in to sum up the main strengths of Lab Camera. So as I mentioned, it covers several science subjects because of its complex functionality. And maybe even more importantly, it develops higher order skills like collaboration, problem solving, and drawing conclusion. I think nowadays these are very, very important skills to have. And yes, let's be honest, kids just love playing with modern digital tools. So if something is in connection with the computer, they automatically are interested. So that's just a good way to catch their attention. Okay, one more thing, our website. Please visit intellisense.education because you can find many resources on our website. So you can register for free, and then you get to know many good ideas how you can use Lab Camera. So there are lesson plans, sample videos, and sample images. Our aim is to help you teachers and to give you ideas how you can make Lab Camera be part of your lessons. So intellisense.education it is. Check out what we can offer here. Besides this resources page, we have a YouTube channel, a blog, and a Facebook and Twitter site. If you subscribe, you will get weekly updates on our science tips and science activities. Sometimes we make fun videos here in the office, so I suggest you have a look at them. Yes, and at last, I'd like to talk a little bit about these things that I pointed out. So we have more than 9 million sold licenses out there worldwide, and we are very proud of this. Then, as I mentioned, this 15% higher exam result is pretty impressive, and yes, Lab Camera has a strong educational value. The lesson plans, I think now we have 150 lesson plans uploaded, but we have a teacher team with whom we continuously are creating new lesson plans and we are uploading this to the website. So I think weekly you can see new ones. Yes, the languages, I guess you will use the English version only, but Lab Camera is available in 29 languages. So if you are interested in the Spanish version or the French version, then you can see that too. Okay, I think that was what I wanted to show with the slideshow. So I quickly stop sharing my screen and turn on my webcam. Yes, can you see my web camera?
I can see you.
Okay, great. So, hi. Now I'm going to do some experiments right here and now. For that, I will use two Chromebooks. This is one, and this is another one. So let's see this one first. Okay, so here let's do the time lapse. Oh, wait. I have to find a good setting. Okay, so here we go. What you can see now on the screen is a flower in a vase. Oh wait, I have to. Oh, it's vibrating. I don't know why. Oh, now it's good. Okay, so with the time lapse, you have only one thing to do before pushing the record button, and it is to set the number, the time between frames. So as I mentioned, it can go from 0.5 seconds up to 1 day. It's an easy calculation, actually, that you have to do before starting the experiment. The only information you need for that is these things. So the length of the process is that you have to know the frames per second and the length of the time-lapse video that you will get in the end. So before I even tell you what the experiment will be, I would like to do this calculation quickly. So the length of the process that I will do will be 15 seconds, which is, no, 15 minutes, sorry, 15 minutes, which is 900 seconds. The frames per second is 25. This is a number that is worth memorizing. And the last thing, the length of the video that you would like to get, let's say we would like to get a 20 seconds long video. So if you divide the, no, sorry, if you multiply this 25 by the 20, you get 500, which is the number of images you will need altogether. So if you divide the 900 by the 500, you will get this, the length of the time between frames, which is 1.8, which can be rounded to 2 seconds. So it means that if I set here in the computer, if I set the time between frames to 2 seconds, at the end, after 15 minutes, I will get exactly the right number of images for a 20 seconds long video. Okay, so this is the calculation, 25 images per second. And then from this, you can calculate this number. Now it will be 2 seconds. Okay, now I need a little bit of assistance from my colleague, so give me one moment. Because I will need another flower. So what you can see in the image, this flower in the vase, which is right here in front of this camera, is an untouched flower, and this other one, which has just arrived, has been frozen. Okay, so here we go with the time-lapse module. I quickly hit the record button and just leave it here. Okay, so after 15 minutes, we will see what I recorded. So this is why I have 2 Chromebooks here, because now I can move to the other one while the first one is working. So this was time-lapse I showed you. Now we can move on to kinematics. So kinematics, for this I will use this camera. What happened to my camera?
Yeah, we lost your visuals.
Okay, wait a second. I can see what. Yeah.
I think it's coming back. There we are.
Okay, great. Okay, perfect. Yes, where was I? So this is the camera that I'm going to use, and this is a simple pendulum with 2 balls in it. So this is the kinematics module.
Excuse me, I don't see it on my screen. And if anyone else, if any of the attendees don't see it, can you please put that in the message box, in the question box?
Wait and see. That's interesting, Amy, because I definitely do see it, but we want to make sure everyone can see it.
Okay.
I'm not getting any messages that people can't see. Do you think it's hidden behind one of your screens, Amy?
Yeah, I'm sure it is.
Oh, look, someone just said, I see it. This is
okay, great. Okay, then then it's on mine. I'll find it.
Okay. Thank you. Thanks for replying, you guys.
Yes.
Okay, perfect. So so yeah, this is the kinematics module. So on the left side of the screen, you can see the camera image, and on the right side, At the moment there is nothing, but if I select these balls, now I selected the red one and the blue one as well, then these lines appear, because right now these balls are not moving, but if I move them, these curves will start to show their motion. Right now it's the displacement in the direction of the x-axis, but I could easily change to the y-axis type of movement. So for example, if you are doing a free fall experiment or something like that, then obviously you would want to use you would want to see the y-axis, the movement in the direction of the y-axis. What is really amazing, I think, is that we have several visualizations that you can choose on the left side of the screen. This is my favorite. Let me just show it to you. So I don't know if you can see it properly, but it draws the graph directly on the camera image. So now you see here are the curves in the coordinate system, and here you can see where this is coming from. So this way children can connect the motion to their diagrams. Okay, for this, I planned to do a quick experiment. So now I stop this one. And I was talking about our resources website, and here it is. I think I've already opened it, yes. So there is an experiment called Calculating Gravity Acceleration from Swinging. So what happens here is that you can see a short summary, then you can see the objectives and the recommendations for use in class, plus a document body. In the document body, you can see all calculations. So on the top, there is an MP4 file, so that's a video that you can load to LabCamera. So I think I've already downloaded it. Let me see. So I load a video to the Kinematics module. Yes, here we go. So if I start this video, you can see it was recorded on a playground, and this is actually me wearing a blue t-shirt, and I can select this blue t-shirt, so it's selected. I don't know if you can see that. So I selected my blue t-shirt, and if I start recording it, on the side the graph appeared. I can change the scale like that, and you can see that by swinging you can draw very nice sine or cosine functions. And why is this good? Besides this, besides just seeing the diagrams, is that from this recorded data you can actually calculate gravity acceleration. So let's go back to this lesson plan, because it tells us that Galilei had some method with which it's possible, and here there is the formula that we would have to use to calculate it. Of course, I don't want to do it right now because yes, that would take a lot of time, but still the fact that from a playground video you can calculate gravity acceleration is sort of interesting. So for example, I can imagine going out to the playground, recording like these things like swinging or seesawing or I don't know what the other things are called on the playground, but I'm sure you can find many physics in the playground. So this was the Kinematics module. Let's move on to the next one, which is motion cam. I won't do any experiments for here. I just show you how it works. So as you can see, you can select a sensitive area. So for example, now the camera image is still the two balls. So I selected the red one. It means that if I start recording and the motion is outside of this selected zone, it won't detect it as motion. But if the moving object is inside the zone, then it will detect it. On the right side, you can select the sensitivity. So now I choose 8 on a scale from 0 to 20, I think. Yes, and start recording. Now I started recording, but it didn't start recording because there is nothing moving on the picture. And if I move the blue, still nothing happens because it's not in the selected zone. But now that it's in the zone, it recorded, and as it stops, the recording stops. And now if I stop the whole recording, I can watch the video that I recorded. Okay, so this is motion cam. It's really kids really love to make some home projects and be some scientists at home who can record I don't know, birds at a birdhouse or animals in the garden, as I mentioned. Okay, and now I think the time-lapse video is ready, so I go back to this computer. Okay, I don't know why it's vibrating. Doesn't look good. Okay. So here you can see the flowers. It changed. So now I will have to. Oh, now it's good. So I will have to push the stop button, and here you can see what happened. So the flower on the left side died because it was frozen. And now from this point, so it's a good start of a lesson to start talking about several topics. For example, reversible and non-reversible changes, or even cell biology. So it can be a very good start of a lesson because it's spectacular. The kids can do it in class. And for this one, we also have a lesson plan. It's called Freezing Flowers to Demonstrate Non-Reversible Changes Caused by Cooling. Here also you can find the short summary, the objectives, recommendations for use in class, and the step-by-step description how to execute the experiment. Okay, so now I go back to this computer. So that was the time-lapse, the end of the time-lapse video. As you can see, it was very spectacular, and you didn't need any special things, just flowers and a refrigerator. So it's one of the main strengths of lab camera, that without any special equipment and lab tool, you can make really cool recordings and measurements. So going back to the other modules, LabCam, the microscope module is the next one. So here, first I will show you how to use a simple web camera as a microscope. For this, I will have to use a different camera, not the one that I was using, because that has autofocus, and that's not good because we need manual focus. So this is the only requirement that you need manual focus. So I quickly change to this new camera that I just connected, if I can do that. Yes, so this is the camera. This one, it's looking upwards. So this is the ceiling that you can see now. I have to change the focus because I would like to put a slide on it. Just I have to change to the different direction. So now you can see that the focus is very close to the lens. You can see my fingers here. Yes. Okay, so this is what I'm going to use. This is a sample of onion epidermis, and I'm going to put this on the camera. So on the camera lens, I still have to play a little bit with the focus. It's not easy to find the right setting, but now I think it's okay. So I quickly take an image. Okay, and zoom in a little bit because I can't really see anything. So now you can see onion cells and even their nucleus. So these little red things are the nucleus, and the big ones are the cells, obviously. Okay, so I zoom out it quickly because now I have to find some reference value, because this is the point that here is how you can measure. First, you have to find a reference value, you calibrate the tool, and then you can make measurements compared to this reference value. So here on the left side, you have to select calibration, and you have to place this small red thing on something that you know the size of. So for example, if we know that the size of this sample is 3 millimeters, then you can write here 3 millimeters, and now it's calibrated. So now if you zoom in to the picture, you can measure different sizes. You can measure distance, you can measure angles, and you can measure area. So now, for example, I can measure the size of this cell. It says 0.44 millimeters. If you zoom in a little bit more, you can measure even the nucleus, and you can measure some angles as well. I also wanted to show you how to use this as a more universal measuring tool. So I will quickly go to the Chrome browser and find a picture of the moon. So I just type moon picture, and it will, for example, this picture looks good, so I will have to download it quickly. How do I do that? Okay, this is not what I wanted. Wait, I don't know why I can't download it. Wait a second, just Okay, now we are good. So save image. Yes, this is what I want. So I quickly save this image, and after you found a good picture, you can load it to Lab Camera. So now I think it's ready. So here we go with Lab Camera again. So I click to load image and select this full moon. So this is what I just downloaded. Okay, the big problem here is that you don't have a reference value. What can we use as a reference value? We can use, for example, the diameter of the moon because this is a value that we know. So now I have to select the diameter like that, and if I remember correctly, it's 3,474 kilometers, like that. So now if I zoom in and select a crater, for example, this one in the middle, I can measure its size. So this crater is 37.84 kilometers. So this is the diameter of this crater, but also I can measure the area of this other one. You just have to go around it, click a few, and then it says it's 444.50 square kilometers. So on the right side of the screen, here are your measurement. Right now, both of them are called measurement ID, but of course you can name them, and then you can say it's measurement 1, measurement 2, or figure out some more creative names. Okay, so this was the microscope module. Then we have universal logger. Now I have to change camera again and put this back here. Just a second. Okay, so okay, here we go with the first camera that I use. So here I will do very, very exciting experiment for which I will use these things here. These are toothpicks. These are I don't know. These are some sweets like gummy bears, but they're not bear shaped. And these are small stickers. So what I'm is get a toothpick and insert it to this gummy thing and put one sticker on the other end like this. So this is going to be my measurement device, and on your wrist you can feel your pulse, and if you put this thing that I've just made onto this spot, you will see it moving a little bit. This is how your pulse. So this is how your pulse can move this thing. I'm going to use a video of this. So I showed you how to create it, but I'm going to use just a video for the experiment, because I'm sure I would move my arm, because if I have to talk and do the experiment parallel, then it will be very confusing. So I just load a video, if I can find it. Yes, here we go. So this is this thing just from very close, because it moves just a little bit because of your pulse. So you have to be very close to this with the camera. So what you have to do, you put a template on it, as this will move left and right. I have to put this template horizontally and start the recording. And as you can see on the side, these little peaks appeared. This is how your heart is beating. So here on the camera, you see that this orange thing is moving. This is my pulse, and on the right side you see the peaks. So this is a very interesting thing, because if you want to buy an equipment with which you can measure your pulse, from this point it's unnecessary, because from marshmallows or these gummy things you can create your own pulse measuring device. So now if I open what I recorded, here you can see the peaks, and if you count the number of peaks in 15 seconds, you can calculate your pulse. It's interesting to compare, for example, an adult's pulse to a kid's pulse, or to different animals' pulse. For example, a bat has some really high pulse rate, and I think a camel has a pulse like 30 or something like that. So it's really interesting why and how these things are like this. So it's also an interesting and creative way to introduce the heart as an organ, or the pulse in itself. Okay, then we have Pathfinder. For this, I
Hi.
will also.
Oh, I'm sorry to interrupt you. I just wanted to give a moment in case anyone had questions because we're running, close to the end. Do you mind if we do a few questions?
Yeah, okay, sure.
Okay, great. Let me just see if nobody has a lot of questions, we can have time probably for this. Is this the last module or is there one more after this one?
There are two left, but I can be quick.
Okay, yes. Well, I think it's good to show all the modules if we can. One quick thing that I think would be interesting to know when you were talking about the time lapse, is it possible to make a recording at night?
Yes, just you have to make sure that there is enough light. So, for example, if you want to record a plant growing, for sure there will be periods which are at night. So then you have to put some lamp next to it so that you will see
Oh, okay.
what you are recording. Sure.
Okay, that's good to know. We did have someone write in that they're trying to download the app and are wondering if they need a special code for this, for their school. Do you know about that?
Well, actually, for if they go to so if they are part of your project, the Level 21 project, then I think they don't need to download the app, but they get it automatically, right? Is that right?
I think so. Yeah, it sounds like during this webinar, there's an educator who wants to, went to try to install it, and it says try now instead of install, which does seem more like that would be a free trial or something. Maybe that's something to we can get back in touch um, and follow up on our end.
Yeah, she can contact the person who's pushed out the apps from the IT department. They'll be able to have those directions, and I can get a hold of her as well.
Okay,
Okay,
perfect.
that
Yeah.
sounds good. Well, I'd like to, if you can kind of quickly finish the modules, then we'll just go straight to the end. If anyone has questions now, speak now. Otherwise, I think it would be valuable for this recording to have the other two modules on here. So you think you can wrap that up in the next 5 minutes or so, Amis?
Yeah, sure, I can do that.
Okay, excellent. All right, well, I'll let you get back to it.
Okay, so we have two modules left. One of them is the Pathfinder. For this, I will load the ants video. So this was an experiment where we put some ants in the middle, and here we put some water, and here some sugar. And we were interested if they are more interested in eating or in drinking. So what you can do in the Pathfinder module is to set the intensity of marking, and then you are good to go. So oh yeah, you can also change color. Okay, so now it's red. That will be perfect, and you can start the recording. So this is the video that I made, that we made from the end. You can also turn to this different display mode where it's even more highlighted, where there is more motion and where there is less motion, and the end result is these two pictures. So this one is this image which is like a heat map, and this other image which is just colored where there was some motion. So as it turns out, they were more hungry than thirsty. This can also be a great home project for the kids. And one more thing, so this is more like part of a biology lesson or a life science lesson. And here I would like to show you something else. This is the recording that we got from NASA. This is Jupiter in the middle, and there are 4 moons around it. I change color quickly to white and start the recording. And go back to the normal mode. Yes, like this. So here, this is the recording of Jupiter and the 4 Galilean moons. And with Pathfinder, you can draw the orbits. So we learn about planets and moons and how they move around. But here you can actually visualize them and see the orbits of these planets. So it's not biology now, but rather physics or astronomy. So it's I think it's really, really wonderful how you can actually see the orbits. So this was Pathfinder very quickly, and just to see graph challenge as well. So as I mentioned, you can choose a curve that you would like to practice. Maybe I change the window a little bit. Yes, okay, so here this is a sine curve that I chose, and now I change to the front camera. Yes, and I get this blue thing. Oh, I flipped the image. Okay, so now I have this blue thing in my hand, and I can select it. And now if I move this up and down, this ball appeared on the screen. So if I move this up and down, the ball moves up and down, but I will have to first choose the speed. Let's say I would like to be a rabbit, so it will be faster than normal. I can change the direction of the movement and go back and forth, left and right, and up and down. Let's say I want to go up and down, and then I can calibrate the movement area. So I don't want to move my hand too much. So now it will be good, I think. Okay. Yes, and now I can start playing. So it says 5, 4, 3, 2, 1, and go. And now I have to follow the shape of the curve. I'm not really good at it, but it says 99%. Oops. Okay, so that was me trying to follow the curve. I have to say I was not too successful in it, but yes. So this is how I managed to do this this sine curve. So I can practice it more and get familiar with the sine shape. So this was the up and down kind of movement, which is the easiest, because if you have to go back and forth, it's much more complicated. Or if you have to go left and right, it's also not so easy. You can also choose different curves, or you can create your own ones. And if more children are playing, then you can type your name here. So this was me. I can write my name here and then save it, and then it appears. Okay, now I don't want to save it, but yes, this is how it works. So children can play with it and learn about the connection of movement and their graphs. Also, if they are wearing some colorful T-shirt, they can also play it like that. They select not such object that I was using, but they can select the T-shirt, and then they themselves have to move left and right, and then try to follow the shape of the curve. That can be more fun, I think. Okay,
This is great. We have to start our closing here, if that's okay with you.
Yeah, sure.
This has been amazing. There's so much information. We can't get it all in, of course, but I just want to thank you very much for your hard work that you've put into these webinars. I know it's not easy. So I think if it's okay with you, I'm going to transfer screens back over to mine.
Okay.
Unless do you have a closing screen with information or webinar? We have it on ours as well.
I think yours is perfect. So yes,
Okay.
you can do it.
Alrighty. Let me go to a closing. There we go. Um, Just so everyone knows, I know people have watched other webinars, but you now receive a certificate of completion by visiting these links that you see, which is great, and you can turn those into your supervisors. But you have to fill out the survey first in order to receive the certificate. Yeah, there's always a little catch, but we want feedback to help with the future of the program and on how we conduct our webinars. So we appreciate all of your input. And it gauges the effectiveness of these webinars. So please take a moment to fill that out. Don't forget to visit our nr21.ctl.net website and news and information for the NR21 educators as well. And I'm going to keep this screen up there up for a little bit longer. There is also a link that will be sent to you of today's webinar that Stephanie will send out within 24 to 48 hours. That will be sent to your email, and it will be on the website as well, so you can share it with others. Yeah, and then in closing, we're super happy that you guys joined us, and thank you, Amis, again, for providing such webinar with full of information. And we will close up and have a great day. Thanks, everyone. Bye-bye.
All right. Bye.
Thank you. Bye.